Assalamualaikum, a very good day to you. So today we are going to learn about lines and angles 2, which is the first chapter of Mathematics Form 3. But before doing that, let me just do a recap about lines and angles 1, which is chapter 9 in Form 1 lesson. So let's go through it. First of all, in lines and angle 1, you will be introduced about angles and lines. If there are two straight lines intersect each other, so we will have intersecting points, and we will also have angles. So angles are being measured in degree. So for example, this could be 120 degree, and this could be 160. This could be 60 degree, and this is 120 degree, and this is 60 degree. Then I'm going to cover with you about types of angles. First one, acute angle. What is that? Acute angle is an angle that is less than 90 degree. Less than 90 degree is called acute angle. 2. Right angle. Right angle is being denoted like this, with a square box. Okay, the right angle is exactly 90 degree. Third, obtuse angle. Obtuse angle is something that is bigger than 90 degree, but less than 180. Bigger than 90 degree, but less than 180 degree. Type number 4 is straight angle. So this is just a straight line with an angle there, and the value of this angle is exactly 180 degree. Type number 5 is reflex angle. Reflex angle is something that is bigger than 180, bigger than 180 degree, but is less than 360 degree. And the last type is called full rotation, or we can call it as a full angle. Full rotation angle is when a line makes one complete rotation. So this is exactly 360 degree. Okay, next. Adjacent angles. Adjacent angle when an angle is being put beside it. For example, you have a line like this, angle like that. And if I have two angles, for example, X and Y, then I can say X and Y are adjacent angles, right? If I have other angles, for example, I draw this again, like this, another one like that, then this could be A, B, and C. Then I can write there that X and C are not adjacent. So what it means adjacent, it means that when two angles are being put side by side together. So that is what adjacent means. So please remember this term, adjacent angles. Okay, next. Vertically opposite angles. This is when there are two angles that is directly opposite to each other. Let me draw an example. Say these are two straight lines, and that two line makes up four angles, and I shall name them as A, B, C, and D. Then angle A and C are vertically opposite angle, as well as angle B and angle D are vertically opposite angles, and two vertically opposite angles are of the same size. So that means A is equal to C and B is equal to D. Pick an example. Let me give you a value for angle C and D. Say angle C is now 60 degree and angle D is 120 degree. Then if you are given this diagram, then you'll know that A, which is equal to C, then A is then 60 degree and B is then 120 degree because they are opposite to each other. Okay, let's take a look at the next one. Next one is about complementary angles. Complementary angles are two angles that add up to become 90 degree, which is right angle. So let me draw an example. So if this is a right angle, I draw another line, a diagonal line that looks like this, and it makes two angles, which is, I call them as A and B. Then A and B are complementary angle. And they need not be adjacent to each other. So for example, if I give you a right angle triangle that looks roughly like this with a right angle over here, then we know that three angles in a triangle will make 180 if you add all the three up, right? So if I name them as X and Y, then X and Y are also complementary angle. And if you add them up, if you add A and B, that is a total of 90 degree. Likewise, X plus Y is also 90 degree. Alright, and the last one, supplementary angles. These are two angles that add up to become 180. So let me draw two angles, a straight line, and then there's a diagonal line. If I call this A and B, then A plus B is 180 degree. Then A and B are supplementary angle. There you have it. That's the quick recap about Lines and Angles 1, which is a chapter 9 in Form 1 lesson. So once you know this, then it will become easier for us to go and learn about Lines and Angle 2. Okay, let's go do that. Lines and Angles 2 are largely resolved around transversal and parallel lines. So let's go through the definition of parallel lines. Example number 1 here. These two lines are parallel. Line AB and line PQ are parallel. And their parallel lines are denoted by an arrow either drawn as one single arrow mark on two lines. Or sometimes you can see double arrow. Probably looks a bit like this. And you see that, then that means these two lines are parallel. What does parallel line means? That means that this line can never ever meet. Even if you extend the line forever, like if you just extend the line until the longest that you can draw, these two lines can never meet. So that is the definition of parallel lines. What about transversals? A transversal is a straight line that cuts through two or more lines. In example 2, line PQ is a transversal because it cuts through three lines. Okay, now I think you are ready to go through the nitty-gritty detail of this chapter. Let's take a look at this transversal that cuts across two parallel lines. We are going to learn a few terms along the way, and these are the terms that you need to memorize because it's going to be very important for you to memorize the name and as well its properties. The first term is called alternate angle. To help you understand what alternate angle is, take a look at this line in red. It looks like a letter Z. From this example, if I call this as an angle D and this angle F, then D and F are alternate angles. There are more alternate angles here. Take a look at the Z symbol, which is slightly deformed there. If I name these two angles as angle C and angle D, then again C and D are alternate angles. One key characteristic of alternate angles is that they are of the same value. So if you compare D and F, D is equal to F. And likewise, C is equal to D. For example, if F is equal to 60 degree, then D is also 60 degree. Likewise, if D is 120 degrees, then C is also 120 degrees. So this is a new term that you need to memorize. So if you have any trouble memorizing or understanding the concept that I've been trying to describe here, try to repeat this video again or refer to your textbook. Let's move on now with corresponding angle. Let's take a look at example of a pair of angles that corresponding to each other. When you're trying to identify corresponding angle, take a look at an angle that is being formed by a letter F. If you take a look at the diagram now, we have an F that is being written in red. It is an upside down F. Let's give a name to these two angles. First is A, and second is angle E. Right, then A and E are corresponding angles. There are three more pairs of corresponding angles. Let's take a look at them one by one. Next is angle B and F. Then B and F are again corresponding angles. Likewise, angle C and angle G. So C and G are also corresponding angles. And the last pair are angle D and angle H. So D and H are also corresponding angles. One characteristic of corresponding angles, the pairs are also of the same value. A is then equal to E. B is equal to F. C is equal to G. And D is equal to H. So that's corresponding angle for you to memorize. And the next term I would like to introduce to you is about interior angles. When you're trying to look for interior angles, look for angles that are being formed by letter C. The first one, take a look at this. So you have angle C and angle F. C and F are interior angles. Second pair is angle D and angle E. Then D and E are also interior angles. One characteristic of interior angle is that the sum of the pair is 180 degree. So C plus F is equal to 180 degree. And D plus E is also 180 degree. For example, if F is 60 degree, then since C plus F is equal to 180, thus C is equal to 180 degree minus F, which is 60 degree, which is equal to 120 degree. Similarly, if E is 120 degree, then D plus E, which is 180 degree, then D is actually equal to 180 degree minus 120 degree, which is 60 degree. So this is the last term that you need to memorize, interior angles. With that in mind, we can do some sample questions. So if you have trouble understanding, please go and rewind back to the section from the beginning until you get the concept. Or you can also try to go through the exercise first to further enhance your understanding of this topic. So do whatever that makes sense to you. Example 1. PR is a diagonal of a parallelogram PQRS. Find the value of A and B. As you know, parallelograms are made of two pairs of parallel lines. Take a look at line PS and line QR. These two lines are parallel. You can take a look at the arrow at the middle of the line there. Single arrow over here. Two pairs of lines that have single arrows, which means that these two lines are parallel. And there are two pairs of double arrow, which is line PQ and line SR. These two lines are also parallel. And you are given the angle 32 degree and 76 degree over here. So find the value of A and B. Let's take a look at this a little bit closer. If I try to draw an oversized line PQ and SR like this, And then I draw another line called a PR line here. And this is point P and this is point R. And somewhere here is the point Q, and over here is the point S, just like in the diagram on the left. I just omit all the other lines there so that we can take a look at the diagram a little better. Remember, line PQ and line RS are parallel, right? And the green line PR, extended PR, is a transversal. And take a look at angle A over here, and then there's an angle 76 here. So take a look at this diagram closer, and you can see the letter Z. Let me try to show you where the letter Z is. Here. In red. That means angle A and 76 degrees are alternate angles. And as such, A is equal to 76 degrees. Make sense? So let's write the answer over here. A is equal to 76 degrees, which is equal to the angle SRP. Okay, next, angle B. Now let's take a look at line PS and line QR. And I draw an extended line there. And there's a line PR here. Remember, line PS and line QR are parallel. Then point P is here, and then you have point R here, and then point Q is somewhere here, and point S somewhere here. And I have purposely omitted all other lines. I just want to show you this. So what can you see again? Yes, you can see again letter Z, which I am drawing using red ink. And this is where angle B is, and this is angle 32 degrees. What is your conclusion? The conclusion is that B and 32 degrees are alternate angles. And as such, B is equal to 32 degrees, which is angle PRQ. Okay, let's take a look at the second example. In the diagram below, PQ is a straight line. Find the value of A plus B plus C. Okay, this is clearly, PQ is clearly a transversal, and we have two parallel lines there that line PQ cuts through. So 70 degrees is given there. So let's take a look at each of these other angle, which is, first of all, A. Can you identify what are the relationship between 70 degree and A? Yes, it's been made of the letter F. Let me draw the letter F there using red ink so that you can see it better. So what can you conclude? Yeah, angle A and 70 degrees are corresponding angles. And A is actually equal to 70 degrees. So that's the first value. Let's take a look at B now. What can you relate between angle A and angle B? Yes, angle A and B are vertically opposite angle. Remember, this is a lesson that you learned from Chapter 9 of Form 1 Mathematics. A and B are vertically opposite angle. And as such, B is equal to A, which is equal to 70 degrees. So let's take a look at the value angle of C. C can be solved in two ways. First, can you see the relationship between C and 70 degrees? Between C and 70 degrees, what is their relation? Yes, C and 70 degrees are supplementary angles. And because of that, C plus 70 degrees is equal to 180 degrees. And then C is equal to 180 degree plus minus 70, which is 110 degree. There is another way to do that. Let's put the value of C here first, 110 degree. There is a second way to do that. Let's take a look at the relationship between angle A and angle C. What is the relationship? Can you conclude from there? Yes, these two angles are made up of letter C. So A and C are interior angles. And as such, A plus C is equal to 180 degree. And A is already known, which is 70 degree, plus C equal to 180. And then C is equal to 180 degree minus 70, which is 110. Okay, now you've got the value of A, B, and C. So what is the value of A plus B plus C, which is equal to 70 degree plus 70 degree plus 110, which is equal to 250 degree. There you have it. Let's take a look at the last example. In the diagram below, PQRS, EFQG, and HRJ are straight lines. Find the value of X. Okay, this is a little bit tough. This is actually an actual CMR exam 2012, paper 1. So this is the value X that we are looking for. Okay, this diagram probably looks a little bit intimidating. Let me try to give you some clues. Let's take a look at the line EFQG, which is this, and then HRJ, which is this. These two lines are parallel. Okay, it's being shown by a double arrow over here. And again, and another pair of parallel lines is FR, and this line over here. These two lines are also parallel. And then we have line PS, which is a transversal. PQRS is a transversal. First of all, let's take a look at the angle FRJ. Angle FRJ and 105 are alternate angles, and as such, FRJ is 105. Then let's take a look at this angle over here, which is angle FRQ. What is the value of FRQ? FRQ is 40 degree because there are corresponding angles. Let me just write a note here. This is the alternate angle, and FRQ and 40 degree are corresponding angle. What about the angle FRH? FRH is equal to 180 degree minus 105 degree. Why is that? Because FRH and 105 are interior angles. So FRH is equal to 75 degree. And now, what about angle HRS? HRS is equal to angle QRJ. QRJ is this one because they are opposite angle, vertically opposite angle. But QRJ is equal to angle FRJ minus angle FRQ, which is equal to 105 minus 40 degree, which is 65 degree. So with all these values, then we can find the value of X. So let me just unclutter this diagram. This is 65. This is 65. This is 40. And this is 75. Then X plus 65 plus 75 plus 40 plus 65 degree is equal to 360 degree, which is full rotation. So what is 65 plus 75 plus 40 plus 65? X plus 245 degree equal to 360. So x is equal to 360 degree minus 245, which is equal to 115 degree. There you have it. So that is the end of Mathematics Chapter 1, Form 3, Lines and Angles 2. You are encouraged to repeat this video again so that you have full understanding of this topic, or at the same time as well, do some exercises in your textbook. And if you do have any problem, check with me, ask me some question. You can either email me at this email address or look up for me in Facebook with the same email address and post me a question on this topic. So with that, I wish you all the best and happy learning. Bye bye.